Eric is the senior space editor at Ars Technica, covering everything from astronomy to private space, wonky NASA policy, and author of the book Liftoff about the rise of SpaceX. Eric has an astronomy degree from the University of Texas and a master's in journalism from the University of Missouri. He previously worked at the Houston Chronicle for 17 years, where he had a great view of the space program there, where the paper was a Pulitzer Prize finalist in 2009 for his coverage of Hurricane Ike. A certified meteorologist, Eric founded Space City Weather and lives in Houston.
Hi, Brian. Thank you very much for this opportunity. I'm thrilled to be here. Let me call up my presentation there. So I love the fact that the defining question of this meeting is what is commercial space? And as we get toward the end of my presentation, I'm going to give you my own personal definition of commercial space, having written about and covered and thought about this industry for about 15, even 20 years. So yeah, we can go to the next slide and just talk about a few words about me and my background. As Brian mentioned, I was a science writer at the Houston Chronicle for a long time. After the Columbia tragedy in 2003, I helped our space reporter Mark Carreau out with the Space Beat. And that became an increasing amount of what I did up to about 2015. At that point, I left to go to a website called Ars Technica to cover space full time. It was what I was most interested in, and offered me the opportunity to go really deep on the emerging new space industry, which was, having pretty transformative effects on the industry. And I wanted to really understand what was happening. And that's proved to be a pretty good decision because the industry's only gotten more interesting as we've gone along. The last administrator of NASA, Jim Bridenstine, was fond of saying that he was the first administrator born after the Apollo program. And we were of a similar age, and I missed the Apollo program by a few months and always regretted that. Up until about 2016, when I saw SpaceX land a first stage on their drone ship in the Atlantic Ocean, I just thought that was incredible, and it felt like we were entering a pretty interesting future. I decided to write Liftoff a couple of years later after seeing the Falcon Heavy launch in Florida. That was both pretty awesome to behold at launch when you had those 27 engines firing away. It was super bright. And then obviously seeing the side boosters come back and make a synchronized landing. It was that point that I realized that SpaceX just wasn't an interesting company, but probably of my generation, at least, the transformative company of the space industry. And I really wanted to understand where they'd come from, and more importantly, for today's talk, is why they were successful where so many other companies had failed. And so I spent most of 2019 and 2020 reporting and writing Liftoff, which just came out a couple weeks ago. Next slide, please. So first of all, let's start with the founding of SpaceX and why Elon Musk did this. Pretty much everyone on this, I'm sure, has heard or read the Russia story, where he went over to Russia to buy ICBM, an old ICBM, for his Mars Oasis project. So I'm not going to repeat that, but it is true. I mean, he went over there several times. Russia didn't really treat him with respect. And he told me that, they would agree to a price and then change it, and then it would keep going up. And he realized that he was never really going to get a good deal from them if he could get a deal at all. But the other part of it, which I think is a little more revealing, is that, Musk came to the understanding in 2002 that if we were going to go out and settle the solar system, it probably wasn't going to happen this century, under the auspices of NASA, or NASA was not going to lead the way. That was not what the agency's charter was. They were exploration. They were not, sort of settling and sending humans to live on other worlds for long periods of time. He created Mars Oasis with the goal of basically putting a small terrarium on the surface of Mars and having a webcam and streaming that back to Earth, and so showing people that life could grow on Mars, and with this idea of really inspiring people here. And his initial goal was to see if he could double NASA's budget. But along the way, he realized that even if you doubled NASA's budget, that probably wasn't going to get you very far. It might one day get you a flags and footprints mission to Mars or something like that. But no BS. He legitimately had the goal, even back then, of human expansion in the solar system and settlement of its worlds. Next slide, please. So this is one of the quotes he gave me for the book. It's fun unless I guess you work for Lockheed and Boeing, but this was sort of his assessment at the time, that basically the way the industry was set up, it was just way too expensive to even contemplate settling other worlds. And it just was designed for sort of these one-off single missions that cost a lot and moved pretty slowly. And then that's why he came to the conclusion that the Mars Oasis project, would not be enough. It's typically, a colorful Elon quote. Next slide. So sort of finally answering the questions of why he founded SpaceX, he realized that, all of this talk about sending humans to Mars or establishing a settlement on Mars or moon bases even was preliminary or was theoretical until you actually had a transportation system that could accomplish the goal. Right? You could talk all day about how you would power a habitat on Mars, or how you would deal with radiation, or how you would feed people who live there, all these kinds of things. But until you actually had a rocket and a spacecraft that could get you across these vast interplanetary distances, that was all theoretical. And so he set about building a Mars transportation system. And the first step toward that goal was building a single rocket. And the idea would be is what's the cheapest way you could build a rocket but still get a payload safely into orbit. And then, eventually he was thinking about reuse, that kind of thing. But literally it did start with a transportation system. And he thought that if you could lower the cost of access to space, you could have a broader economy in low Earth orbit. And once you get an economy in low Earth orbit, then it just sort of builds upon itself. So this was kind of the final awakening that galvanized him to found SpaceX in May of 2002. He had about $180 million from PayPal, and he ended up putting $100 million of that into SpaceX. Next slide. So one of the interesting things that I found when I reported the book is that, if you were an entrepreneur wanting to do space at that time, there were lots of warning signs. You were kind of walking through a graveyard on the way to orbit. And that was really pronounced actually for SpaceX, kind of looking at some of the different places that they started at. So I'm just going to run through 4 kind of examples of failures that were all around them when it came to spaceflight. So next slide. So their first place they went for a test site was Mojave Air and Spaceport. By October of 2002, they were testing a gas generator there, working with Stu Witt. And every time you go up there, you could see a rotary rocket, which was a pretty stark reminder of the perils of privately funded, rockets, commercial rockets, going to orbit. They had this ambitious idea for a single-staged orbit vehicle, and they'd failed just a year earlier. So that it was interesting. SpaceX was at Mojave, and they were working with Stu Witt to try and, build an engine test facility. Tim Buzz, the launch and test director for SpaceX, told me that they had stakes in the ground. They were ready to move forward with building a facility. And kind of at the last minute, Stu Witt said, we can only do a 30,000-pound thrust engine. And SpaceX was like, well, the Merlin 1's going to be more than twice that powerful. And so they pretty quickly, toward the end of 2002, started looking elsewhere. Next slide. And so they ended up, of course, in McGregor, Texas, which offered even a more stark reminder of the failures that they potentially faced. Andy Beal, a Texas banker, had put $200 million into his company, and he was in Dallas, and he found this site and built it up in McGregor, about an hour and a half south of Dallas. And it had some success in building this really large engine, but basically ran into the problem that he was competing against Lockheed and Boeing and Aerojet, and they weren't willing to give him an inch, and he was trying to get NASA contracts and DoD contracts, and he was not getting anything. And it's really interesting. You go back, you can find some of the press releases that he issued sort of toward the end of Beal Aerospace and afterward, and he was pretty jaded about the whole space industry, and he ended operations at that company in 2000. and SpaceX showed up a couple of years later. But it's interesting to sort of think about the fact that Musk was trying to do this exact same thing, and he had no problem moving into a launch site that a company that spent twice as much money, that he had failed. Next slide. Another example is a nearby company, Microcosm. It was also just down the road from SpaceX's original headquarters in El Segundo. And interesting, they had a plan to develop a low-cost rocket called Scorpius. They started on a suborbital, but the plan was to go to orbital. And the idea was similar to the Falcon 1. You would put it on the back of a truck, roll it out to the launch side, roll it up and turn it vertical, and it would go. They did not have the funding that SpaceX had from Musk. They were trying to survive on SBIR grants and other things from the DoD. Hans Koenigsmann, who was the fourth employee at SpaceX, started at Scorpius. He did avionics for that rocket, learned a lot about failure. And it's so many other key early employees from SpaceX came from there, Gwen Shotwell, Ann Chinnery, Phil Kassouf, among others, who came a few blocks over to SpaceX. But again, sort of another lesson in the perils of getting to orbit. Next slide. And then finally, we have their first launch site, where they never launched from, obviously, initially the Falcon 1, but Vandenberg Air Force Base. In the 1980s, there had been a company called American Rocket Company. And what surprised me when I looked at this was going back and seeing the founder, this really colorful guy named George Koopman, whose claim to fame was doing the stunts for the Blues Brothers movie. But he'd raised, tens of millions of dollars, convinced Jim French to go there from JPL, and also Mike Griffin sold off some of his savings in the mid-1980s and moved from Virginia across the country to California to work for them. French and Griffin became pretty disillusioned because George Koopman was making all these scheduled promises that they knew they couldn't keep. Anyway, if you read that quote, this 90% reduction in launch cost becoming the FedEx or UPS of space, that reads to me just like something that Elon Musk would say. And this was George Koopman, a decade and a half earlier. Again, sort of, one of these commercial companies that tried to do at Vandenberg what SpaceX wanted to do and fell flat. So anyway, there are others speaking at this symposium who know a lot more about commercial space than me, and certainly its history, especially about the 1980s and 1990s. I didn't really get serious about covering space until about 10 or 15 years ago. But what I think stands out about SpaceX is where most of the other early commercial efforts ended in failure, and almost all of the launch efforts, it makes the success of SpaceX stand out that much more. Before SpaceX came along in 2002 and had success several years later, there was a lot of talk about the promise of commercial space and lowering the costs and things like that. But it took SpaceX to turn a lot of that rhetoric, I think, into reality. And one of the things that I want to leave you with today with this speech is that the success of SpaceX, I think, really created a glide path for the rest of the commercial space industry to follow upon, certainly over the last 10 years as we've seen this acceleration in private equity funding for commercial space. Next slide, please. Okay, I know we're all virtual, but Brian is in Huntsville, and I just wanted to bring a bit of local flavor to this talk. Back in 2003, when SpaceX was looking for a launch site, a backup launch site. Actually, they needed an equatorial launch site to launch a satellite from the Malaysians. Musk called Tim Mango, who was in Huntsville at the time, and he was at Redstone, and he had responsibility for the Army base on Kwajalein. He called up Mango, talked for a couple of minutes, and he said, "Hi, I founded PayPal, started a rocket company, and Elon kind of has this accent, And Mango thought he was crazy and hung up on him. But eventually they got together, and Musk and some of the other vice presidents visited Mango in Huntsville in 2003, and they wanted to take him out for a local dinner. So they went to the Old Greenbrier restaurant, and Musk was encouraged to order the catfish. And as Tim Mango told me, the catfish at the restaurant comes with the head on. And Elon was apparently not too amused by this, but did end up eating his dinner anyway. And I went there a couple of years ago with Todd May to have lunch. So that was nice. Okay, let's talk about. Let's go to the next slide. So this is a launch image of Flight 1. It's on the cover of the book. I think it's a gorgeous image. A couple of things about this. First of all, notice the date, March 24th, 2006. This was really fast because the company had only been founded in May of 2002, so less than 4 years later they launched. And actually they had been counting down on the launch pad in December the year prior, before they had some issues. So, they had gone through and built their initial rocket, built up 2 different launch sites because Vandenberg didn't work out for them. And now we're, 3.5 years later, as I say, we're counting down to their first launch attempt. So they had moved pretty quickly. There's a funny story too about the countdown that I think really illustrates kind of Musk's mindset. So Chris Thompson was the launch conductor in this flight control room on Kwajalein. Kwajalein Island is in the atoll. This in the Pacific. This is the largest natural lagoon in the world. And then they were launching from about 20 miles away on Amolek Island. This is a picture of Amolek and the rocket launching. So they're in the control center on Kwajalein, and like about 20 minutes before liftoff. And this is the very first time they've launched this rocket. And Elon had just been coming over to Chris Thompson and having these really aggressive conversations about ordering aluminum for the Falcon 5 rocket, which was at the time the plan was to build a rocket with 5 engines, hence Falcon 5. And, Thompson was just kind of like thinking to himself, we're launching a rocket here. And like every command sent to the rocket goes through me. And Elon is just, focused on the future as much as the present. So finally, about 20 minutes before the last one, Thompson says, look, we've got to launch the rocket. And so Elon kind of goes to the back of the room, and Tim Buzza, the launch director, turns to Thompson and says, what the hell's going on? So anyway, it's just kind of funny that he always is thinking ahead and sort of, trying to figure out what comes next, even when his very first rocket that they put so much blood, sweat, and tears into getting on the pad was launching. If you look at this photo of the launch, you can see the fire coming out of the engine, but you can also look above there, above the nozzle to the base of the first stage, and you can see the engine is also on fire. The tremendous picture showing that there was a fuel leak leading to the Merlin engine, and actually it caught fire a few seconds before launch, and the rocket goes up for about 30 seconds, and then came back down and crashed into the atoll. Next slide. The payload on this rocket was Falcon Sap 2, built by the Air Force Academy. Here it is after the launch, and ironically, it ended up a few feet away from the hangar it was integrated in. So it did not go very far. Anyway, it's just kind of a fun picture. Next slide. Hans Koenigsmann took this picture and shared it with me, and got permission from Elon to use it in the book because I think it's pretty poignant. This is a picture inside the hangar. They spent a couple days gathering up all the pieces of the rocket on Amolek, and then sort of as part of their analysis. And it's just kind of a nice shot of him. I'm not sure whether he's angry or pensive or thoughtful here. He would be angry shortly after that, though, and I'll talk about that a little bit. So what happened was there was this fuel leak, and initially Musk blamed Jeremy Holman, who was basically Tom Muller's deputy on their propulsion team, and the lead technician Ed Thomas, who everyone at the company respected, and said that they had failed to apply enough torque to this bolt that had, as I say, had leaked and caused a problem. And he even called them out publicly. There's a shouting match back in the factory between Musk and Holman. It was not great. But what ultimately was found to have happened in a DARPA report, and SpaceX realized this as well, they left this engine out on Kwajalein for more than a month, from Christmas of 2005 into the January of 2006, because it took a couple of days to roll the rocket back into the hangar, and they thought they'd only be gone a couple of weeks. If they all didn't catch the last flight from Kwajalein back to Honolulu to LA, then they would miss their entire holidays with their family members. And so ultimately it was that exposure that caused this bolt to corrode and sort of the sea salt spray. So not a great moment, but they would come back from it. I just think that this is kind of a pretty profound picture. Okay, so flight 2, next slide. So this is a great shot because you can see Amolek Island. The ocean is on the right. The lagoon is on the left, and you can just see how small Amolek is. This helicopter shot of the launch. So what happened on flight 2 was this rocket did great. The first stage burned like a champ. And then the second stage separated, but then the fuel in the second stage started sloshing around. And what was really interesting about this, and it spun out of control, what was really interesting about this one to me is it illustrated the sort of the peril of going fast, because what Elon always wanted to do was go fast, and he wanted to not spend money. And so they had run a bunch of simulations. Steve Davis had run a bunch of simulations of this slosh. And in most circumstances, or the vast majority really, it wasn't a problem. But in a few things where a bunch of different things went wrong, in a few simulations, it did spin out of control. Elon knew about the risk and ultimately accepted the risk. And so he didn't get as mad after flight 2. But again, like if that had happened at a traditional space company, more simulations would have been run, and they probably would have put slosh baffles in the second stage. But again, SpaceX sort of has this iterative philosophy where they're going to go fly and test their hardware, and then if there's a problem, then they'll fix it. Next slide. Just another slide here showing Amolek. This is actually from the opposite direction. So the ocean is on the left and the lagoon is on the right. But you can just sort of see, again, how small Amolek was. You have the hangar there in the background, the launch tower, some boat docks, an helipad, and that's basically it. The island is smaller than 4 standard city blocks, and in the distance you can see Mac Island. So yeah, next slide. Okay, so flight 3. This is almost a year and a half after flight 2, and this one didn't even get as far as flight 2 because it got to first stage separation. The first stage started to fall away, and the Merlin engine actually fired a little bit of residual thrust, and the first stage then collided with the second stage after this burn, and it destroyed the mission. And what had happened is in those 17 months between the 2 flights, SpaceX had upgraded the engine to the Merlin 1C, going from an ablative design to a regeneratively cooled design, and they had not quite noticed it. It was just this very slight discrepancy in terms of thrust as some of the kerosene fuel used to cool the engine remained in the thrust chamber. Next slide. And yeah, here's a quote from Elon sort of discussing why they didn't see it during tests in Texas. So yeah, it was like basically 10 PSI thrust and destroyed your rocket. And so what happened was the first stage, the stage separation was commanded to be 1 second after the Merlin engine stopped firing the first stage engine. And so all they did for the second flight was go from 1 second to a 5 second difference for the fourth flight. But there was some question of whether there would actually be a fourth flight, because by the summer of 2008, SpaceX had burned through all of its money from Elon and also from some NASA grants that I'll talk about in a minute. They had no more hardware except sort of the parts for one final rocket, the fourth one. And this was when the Great Recession of 2008 was really starting to deepen. So there was no real way to raise private capital. Next slide. This is a quote from Ann Chinnery. She was Air Force, and she went to SpaceX to help them set up Vandenberg initially. And this was the mood. And as I say, after Flight 3, they were sort of joking about whether they were going to have to buy their own tickets back to the mainland from Kwajalein. But that failure set up this 8-week period, which really is the narrative heart, I guess, of my book. It's just this amazing period during which all kinds of things went wrong for SpaceX, and they persevered, and it really hardened the DNA for kind of this company that they would become, or this hard charging, devil may care, launch at all costs mentality that they have, that has really propelled them forward. Next slide. So the fourth flight, no one wanted to put a commercial payload on it because the rocket had already failed 3 times. So I'm not launching on your rocket. So Chris Thompson, he was the director of structures, vice president of structures at SpaceX, had just a couple of days to put together their payload for the Flight 4. Elon had given the company 6 weeks after Flight 3. He said, you have 6 weeks to go launch the 4th rocket, or else we're going under. And so this is Ratsat, and that's Rikiki, Amador, Thompson, the 3 structures guys who built it, put their name on it. And this is just kind of a fun picture of Ratsat in being integrated, I guess, in Hawthorne before it was shipped out to Kwajalein. Next slide. So they had always sent the first stage by barge out to Kwajalein because it takes 28 days by sea, but it's much cheaper. In this case, they didn't have 28 days to ship the rocket after they'd integrated it. So in early September, they found a C17 Transport, paid about $500,000 for it. And here's an image of them at LAX loading the first stage onto the C17. It's not fueled. And the plan was to fly it from LAX to Honolulu, overnight, refuel the plane, let the pilot sleep, and then fly from Honolulu to Quad. So it's less than a 2-day transit. And then when Quad, you would put it on a boat and ship it over to Amolek. Next slide. And so to save money, about 20 or 25 engineers and technicians flew along inside the C-17. It was like a real party atmosphere. Here they are with their feet up on the launch cradle. The rocket is the white thing. To the right there in the top image, and they're just kind of having a good time. They had a guitar and stuff. It's like, flying with a rocket across the Pacific inside a C-17 when you're 20, that sounds pretty freaking cool to me. The problem is when they started descending into Honolulu, the pressure inside the rocket was less than that inside the C-17 hangar or payload area. And you see a rocket never wants to be at that. Rocket always wants to be overpressurized, right? So next slide. As they're descending into Honolulu, the rocket starts imploding. And it's really bad, obviously, and doing all damage like the delicate structures inside the vehicle. This is a picture of Florence Lee sort of supporting Zach Dunn as he climbs up there, and there were no tools. No one had brought like a tool chest because no one expected to work on the rocket in flight. One of the Air Force people on the plane produced like a tool chest that had one wrench, and so Zach Dunn, next slide. Here he is, Zach Dunn, in his early 20s, is in charge of the first stage propulsion system. So it falls to him to crawl inside the inner stage, sort of go entirely inside the rocket to try to open this valve, even as it's like pinging and popping, and at risk of imploding completely and crushing him and damaging or killing other people on the aircraft. Like I said, it was a pretty hectic moment. And so, they get to Kwajalein, they get to Amolek, and it's early September. They've got just a couple weeks, and over the course of 7 days, they literally took the entire first stage apart, replaced slosh baffles inside the first stage, put it entirely back together, pressure tested it not with nitrogen, but the only consumables they had to hand, which were kerosene and liquid oxygen. So this was pretty desperate. Like all of their procedures and everything were like tossed aside, and they still made it to the fourth launch. And of course, on September 28th, 2008, the Falcon 1 rocket on the fourth try did make it to orbit. And was big moment for them. But that the company still wasn't saved. Musk told me that, he was so tense, and that the financial situation was so dire that he didn't feel anything but a little bit of relief after that flight, because it meant that just that day they weren't going to take a bullet to the head. They were, they would survive that day, but there still was the cash crunch, and there were nobody was waiting. Nobody was waiting to sign more launch contracts. And even if they did, to be months and months before they got paid, because they didn't have any more rockets ready to go. And so next slide, please. So SpaceX in 2006 had gotten a COTS contract from NASA. This was about 278 million, I think, and maybe 287. I get that confused. They got a COTS contract, a development award to start working on the Falcon 9 and Cargo Dragon spacecraft to carry cargo to the International Space Station. And that really allowed the company to grow dramatically from about 150 people to nearly 1,000. And they moved in 2007 into their headquarters at Hawthorne, California, and that's where they've been ever since. But by September of 2008, the financial situation was still dire. Gwen Shotwell said they had a couple of weeks of payroll left, and then she was out of money. And the company would have gone under again if they didn't get the CRS, or Commercial Resupply Services, operational contract from NASA in 2008. So this was the contract worth more than $1 billion to actually fly Cargo Dragon and missions on the Falcon 9. And this was, the quote is what Elon told me about that, about getting that award, which I think was pretty striking. So next slide. So a couple of thoughts about why SpaceX succeeded where a lot of other companies failed. First of all, if you spend any time around Elon, he's got this really intense personality, I think it's safe to say. Sometimes it manifests itself in anger, and sometimes he can be very funny. But he has this incredible drive that every day I think he wakes up trying to think about how can he go faster than he's been going. Speed is the essence, and so he's constantly trying to move things forward. And he has a pretty demanding management style, but he ultimately does get results. And one thing that became really clear to me as I reported the book is he had this exceptional ability to hire brilliant engineers, but also they would be willing to basically give it their all. They would be all in on his ideas and trying to carry them forward. And it was that ability to identify these people, hire them, and then motivate them, which really set SpaceX apart, I think, from other companies. He also got very lucky, or also sort of, probably a mix of luck and skill in hiring his first vice presidents, Tom Mueller, Chris Thompson, Tim Buzza, Hans Koenigsmann, Gwen Shotwell. They were all people who were about 40, their 30s or 40s. They had experience working for Boeing, or other companies. Shotwell had worked at the Aerospace Corporation. So they were kind of establishment people, but they were willing to be molded by this Silicon Valley guy who was a little bit crazy, and had different ideas about doing things like vertical integration, things like that. And they really, helped those. So the vice presidents were experienced, but then he went out and hired basically students, undergraduate students or people in graduate school. And sort of those vice presidents worked well with those students. SpaceX also had very fortuitous timing. After 9/11, so almost 20 years ago, DARPA created the Falcon program, ironically named. It was not named after the Falcon 1. Force applications and launched over the continental United States, something like that. Falcon. Anyway, it was the idea. One part of that was hypersonics, and the other part of that was responsive launch. And so SpaceX was able to get some DARPA grants for that. It also, SpaceX was just starting to have some success in 2005 and 2006 when NASA was making its decisions on COTS. And so they were in a position to meet that demand. And so those were two important government programs that helped them. They also, frankly, made their own luck. Elon had enough money, $100 million, to really get the ball rolling in terms of developing and building the first Falcon 1s and getting the company in place. The rocket had a pretty good design. It was fairly simple and straightforward, but also, 1,000 pounds to low Earth orbit is not nothing for a small satellite launch vehicle. And he took risks, right? It was this whole idea of trying to go fast and not doing the way things had always been done in traditional aerospace. And that resulted in some failures, like the second launch of the Falcon 1, but obviously it also resulted in some pretty great successes. And then finally, we just talked about the contract awards that NASA got, which were, they saved the company in 2008, basically. Next slide. So what are the implications of a successful SpaceX? I think they've changed the market in terms of how engineers are hired and motivated. And like SpaceX has this well-deserved reputation for burning through talent. Right? You go there, you're going to work 70, 80, or 90 hours. But it's these engineers are not blind to the decision they're making. They're going to SpaceX and they're getting to touch hardware and see it fly. They're not mired in studies. And they get a piece of the company in terms of stock, and that stock is extremely valuable. And so, it's a different thing than having an expectation of going to a Boeing or a NASA and expecting to sort of stay there for decades. A lot of people going to SpaceX maybe stay there for 5 years or 10 years at the most, because it's a difficult place to work and you really are putting your all into it. The chart here shows how, if you go back and look at that white line, kind of 2008, 2009, for decades there had been almost no private equity investment in commercial space companies. And then after you start to see the success from the Falcon 1, all of a sudden the amount of investment shoots up. And again, I think that's largely the SpaceX effect of showing that commercial space can execute. There's obviously been disruption, across the industry in terms of launch contracts, and we've seen it in competition with ULA, but also the European Space Agency, China, Russia. SpaceX has really remade the global launch industry, and I think it's made it more competitive, and it's been good. It's been good, frankly, to shake things up. The success SpaceX has demonstrated has really provided new pathways for NASA. NASA did a study after the Falcon 9 rocket and Dragon came along and said, what would it have cost if NASA had tried to develop this with traditional means? And it was 4 to 10 times as much. I'm going to talk briefly and a little bit about, whether or not we can extend this model beyond low Earth orbit. Next slide. Okay, we're wrapping up here, but I wanted to talk just a little bit about commercial space. My definition of that is a purely commercial space company builds things on speculation. There's no assurance of profit. Here's what Gwen Shotwell said about the Falcon 1 compared to other rockets at the time. So yeah, commercial space in my mind is when you're building things on speculation. You're not being paid by a government agency to build it. Next slide. So there's obviously a continuum. There's almost entirely pure commercial space examples. I would count the Falcon 1 on that, Falcon Heavy, Electron Launcher 1, Rocket 3.0, Terran 1, Alpha, RS-1, New Shepard. These are all vehicles that have basically were developed, by and large with private funding. Entirely traditional space examples, Space Launch System, Saturn V, Atlas and Delta rockets, Orion. Those are all vehicles that were funded entirely pretty much with government funding and very little to no private investment. And then you've got some interesting examples in between, right? Crew Dragon, that vehicle was mostly funded by NASA, but SpaceX certainly put some skin in the game, and they're starting to use it for commercial missions. Starliner, I'm not sure how much private money went into that. I don't think a whole lot, although I think Boeing is certainly spending more on it now as they're trying to get it to the launch pad for a second time. The Falcon 9 is an interesting one because it was sort of built on the back of the commercially developed Falcon 1, but NASA did give some money to SpaceX, although I think the amount of money that SpaceX got for COTS is kind of overplayed because it ended up being about $400 million for development. And for that $400 million, NASA got Cargo Dragon, Falcon 9, and a launch pad. So that's a pretty good value for a launch system like that. And then Vulcan Centaur, I would say that's somewhat commercial space, but most of that was paid for, with the launch services agreement that ultimately paid $530 to Northrop, $255 to Blue Origin, $1 million to ULA. I mean, that's a lot of DoD money going toward elements of Vulcan Centaur. Next slide. So where do we go from here? As I said, I think the big question is whether this new public-private partnership can be extended from low Earth orbit into deep space. Whether we end up with a continuum of companies more on the commercial side versus on the traditional side. And HLS, the Human Landing System, is going to be a big test of this because NASA is trying to do that with a more public-private partnership model. We'll see how that shakes out with these awards coming up maybe next month and in the future. I know Congress has sort of made some noises about wanting to turn that more into a traditional contracting method. And so we'll see. And I think a lot of it will depend on the success SpaceX has, not just with commercial crew, but also with the Starship program it's building in South Texas. Just want to show you a few final photos, and then I'll be happy to take questions. Next slide. So this photo is just to give you a sense of Amolek the day after the Flight 1 failure. They were out in the ocean trying to find pieces of the rocket, trying to find the parachute. And it's just, they've got like a big trash bin there in the background where they were correcting these parts. So it's just kind of a nice image. Next one, please. This is a great picture. This is after their first successful static fire test at Vandenberg Air Force Base, just before they found out they were going to have to pick up and move quickly to Quad. From left bottom around, you've got Diana Molina, who was doing communication for them at the time, Bulent Altan, who was avionics, Phil Kassouf, who was avionics. There's Jeremy Hallman to his right, who was propulsion, and then Tom Muller, who was the architect of the Merlin engine, propulsion, key person at SpaceX, obviously, and then bottom right is Ann Chinnery, who did a little bit of everything. And if you look closely, you can see the alcohol there is Glenlivet Scotch whiskey. The brown paper bag, I am told reliably, is malt liquor. And I told Tom that I thought, wow, you go really hard if you're drinking malt liquor, because it doesn't take much of that to mess me up. And he's like, yeah, we went pretty hard. So yeah, I mean, it was, they worked hard and they partied hard. So this is on the runway, I think, at Vandenberg, sort of waiting to go back down to LA. One more slide, I think. One more. Yes, and this is just a picture of the Falcon 1, a lot of the Falcon 1 launch team, and it's mostly men, as you can see. But there's a few women. Flo Lee is at the bottom there, and Ann Chinnery's a row above her. And then if you look toward the top, there's Elon sitting there, just kind of happy-go-lucky, you would think. And then Tim Buzz, the launch director, at his right. But I just think that's a nice photo showing them all about 15 years ago at the very beginning on Amolek. So yeah, I think this next slide. So Liftoff is out. It was just a real privilege for me to get to tell this story because I think it is one of the great space stories. It had been told in bits and pieces in different places, but it was nice to be able to go back and talk to everyone who was involved in those early days, both who are still at the company and not, and really put together kind of a complete story of what happened and what they had to go through to get the rocket to orbit. And then finally, if we can go to this picture of me, I want to show you one final thing. So in the presentation. So I don't know if you can see me or not, but it is St. Patrick's Day, and the initial mission patch for the Falcon 1 Flight 4 was the first time they put 4-leaf clovers on a mission patch, and it was a success. And so every mission patch that SpaceX has done since then now has a 4-leaf clover. So there's a little bit of superstition everywhere, I think, in the space industry. So thank you.